Greetings and welcome to the introduction to astronomy. In this lecture, we are going to give an overview of the solar system that we'll be covering over the coming lectures as we look at all the solar system objects in detail. But today we're just going to look at a brief overview and get a little idea of what is coming in future lectures. So what do we find in the solar system? Well, it changes depending on the time. Right now, we know that there are these things in the solar system: one star, 8 planets, 5 dwarf planets, more than 150 moons, plus asteroids, interplanetary gas and dust, the Kuiper belt objects, and the comets. Now, in ancient times, this was quite different. We thought that stars were part of the solar system, which we now know they aren't. The one star that is our sun. The number of planets has increased from 5 to 8. The one moon that was known has now multiplied to over 150. Meteors really are within our atmosphere. Comets were known, however. So you can see how many new things have been discovered since ancient times. And ancient times isn't necessarily all that long ago, going back into the mid 1700s, before the most recent before Uranus was discovered. That was all that was known. Now, what about their masses? Where is all the mass in the solar system? Well, the sun contains 99.8% of the mass of the solar system. So it is the solar system. If we look at Jupiter and Saturn, they contain about 90% of the remaining matter. And that leaves 0.02% of the remaining mass for everything else. That's all of the other planets. So the other 6 planets, that includes all of the comets, the asteroids, the moons, all of the other debris that we'll be spending a lot of time talking about, but is actually a very small percentage of the mass of our solar system. So let's look at the planets first. So what is a planet? Well, in 2006, we gave a definition as to what a planet actually is, and it has to do 3 things. First, it has to orbit the sun. Second, it has to be massive enough that it has pulled itself into a spherical or ellipsoidal shape. And 3, it has to have been able to clear its orbit of debris. So there are 8 objects pictured here, Mercury out through Neptune, that meet all 3 of these criteria and are planets. And we will look at all of these planets in far more detail coming up. Now let's look at some of the smaller objects. Well, we have moons in the solar system. Well, this is not a complete picture of all the moons. This is just a few of the moons that exist. And we start off with our moon, the only one known in ancient times, and one of only 3 moons in the inner part of the solar system. We also have one moon here known around an asteroid. There's actually more as well, but one asteroid has a moon shown here. And then we see lots of moons in the outer solar system. Now, the only thing that we do picture our Earth here just to give you a sense of scale, that you can take all of these moons and you really don't even make one Earth. So while there are a lot of them and some of them are fascinating that we will look at, they are not really a big part of the mass of the solar system. So how about the dwarf planets? Well, a dwarf planet has to do 2 things. It has to orbit the sun, and they have to be spherical or ellipsoidal. So they meet those first 2 criteria for a planet, but not the later one. And as I didn't emphasize, the moon is an object that orbits a planet or other larger object. So some of the moons are as large as some of the smaller planets, but they are not planets in themselves because they do not orbit the sun. So here we see the 5 known dwarf planets, the best known of those being Pluto and Ceres. And you can see by the images, these are the 2 that we have actually explored. We have had close-up images and have studied these in detail. The other 3, Eris, Haumea, and Makemake, have not been explored in detail, and we see them only as we can see them from Earth as blobs of light. Now there are also a lot more small objects. We have the asteroids, meteoroids, and comets. We see some of the asteroids here. And the asteroids, several of them that have been imaged and that we have actually gotten relatively close up images of. To give an idea, Ceres, which is actually one of the dwarf planets, is pictured here about 600 miles across. Vesta, a little smaller than that, almost half that size. And then three others that have been observed closely here. But you can see again how small they are relative to these. Most of the asteroids are relatively small objects, just tens of miles across. Now, what do these have to be? Well, these objects have to be things that orbit the sun. So a very basic definition. You notice how they are not shaped spherically. See how they're all odd shaped as compared to Ceres, which qualifies as a dwarf planet. Now let's look at how things orbit in the solar system. So when we look at them, the planets all orbit in the same plane. The planets shown in blue here are all orbiting in the same plane. And in fact, you can draw them on a piece of paper, and that's a relatively good approximation of the solar system. When we look at things like dwarf planets and asteroids shown in the red here, we start to get to orbits that are a little bit tilted. Not always horribly tilted, but much more tilted than what we see with the 8 planets themselves. And not shown in here are comets. Comets would have highly tilted orbits and could come in any direction. And in fact, sometimes they're so tilted that they're coming in backwards. Now let's look at the properties of the planets. So what do we see? Well, this is just some general properties. Distance, going from Mercury as the closest to Neptune at the furthest. Mercury a little over about 0.39 astronomical units away, and Neptune about 30 astronomical units away. Revolution periods going from about 88 days here for Mercury, about a quarter of a year, and up to 164 years for Neptune. Sizes, we note that there's a big difference in sizes, that we have much smaller planets in the inner solar system and much larger planets in the outer system, the solar system. And that is by diameter. That is also by mass. You can see that there's a distinct difference there. And there's also a distinct difference in density. Densities are very large in the inner solar system, smaller in the outer solar system, telling us about the composition. These are rocky and metallic materials, whereas the others are more gas and icy material. So let's think about our solar system to scale, and we can imagine scaling the sun down to about 25 centimeters or about 10 inches in diameter. Mercury would be less than a millimeter in size and would be 10 meters away. So within those 10 meters between Mercury and the sun is nothing. Earth would be a little over a millimeter in size and about 27 meters away, almost 100 feet away from the sun. And between it, only two small little things about a millimeter in size or less. Jupiter would be nearly an inch in size, tremendous compared to the others, but would be 140 meters away, well over a football field's worth away. Go out to Pluto. Pluto would be tiny, half a millimeter, and would be over 1 kilometer away. So trying to make a scale model of the solar system is very difficult, simply because there's so much empty space there that if you scale things to the correct sizes, the distances will be so tremendous. And in fact, there are places where you can have walking trails of a scale solar system that will stretch out over kilometers to be able to see things to this kind of scale. Now, if we continued on, we'd have Alpha Centauri, which is the nearest star. It's close in size to our sun, so about another 25 centimeters, and would be 7,500 kilometers away. So on the surface of the Earth, that's a good chunk of the way around the surface of the Earth. So in between those, just a few little specks. Again, most of the universe, as we looked at in previous solar system and the universe, is mostly empty space. Now, where do these objects get their names? Well, they are named by the Astronomical Union, gives those, so the conventions are set by the IAU. which is the International Astronomical Union. So we look at some of the examples here. For the most part, planets and moons are named after the gods and heroes from Greek and Roman mythology. With one exception, Uranus has moons named after characters from English literature. So everything else from Greek and Roman mythology, Uranus a little bit different. Comets are named after the discoverer. So if you discover a comet, it would have your name attached to it if you are the first to discover it. With most automated methods looking for comets now, many comets currently found are found by automated telescopes and are named after them. Asteroids are named by the discoverer. So if you discover a new asteroid, you get to pick a name subject to certain restrictions on it, but you can select a name for that asteroid. However, since almost all asteroids of significant size to be visible on Earth have been detected by now, that there are no further namings, very little chance of detecting one that would end up being named. So while you technically could name an asteroid, it's not very likely that this would ever happen. How about features? Naming features, let's look at some of the craters. How do we name craters? Well, it depends on where the crater is found. On Mercury, they are named after artists, musicians, painters, and authors. On Venus, famous women for larger craters and female names for smaller craters. The moon, scientists, engineers, and explorers. Mars continues that with the larger craters for scientists, for scientists and writers and others who contributed to the study and lore of Mars. So writers who wrote about Mars. Small craters are actually named after small towns and villages of the world. So depending on which object you're looking at, they get their names through different sources, and they are again approved by the International Astronomical Union. Sometimes you'll have common names that people refer to things by, but the official names are set in this way. So let's go ahead and finish up with our summary. And what we looked at today is that the solar system contains a wide variety of types of objects. But where is all the mass? All the mass is in the sun. That's where almost all the mass of the solar system is. The smaller solar system objects have really varied structures and features, and we'll be looking at that in more detail over the coming chapters. And we looked at how a scale model of the solar system is next to impossible to actually construct because of the tremendous distances between the planets relative to their sizes. So that concludes this lecture on the overview of the solar system. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.